2012, number 6, from the A-B test. This one wasn't on the BC test. And it gives you some information. It gives you a velocity equation, and it asks you between 0 and 12, when is the particle moving to the left? Moving to the left is a question of velocity. You want your velocity to be negative. So we really should be setting our velocity equal to 0 to figure out where we might change from positive velocity to negative velocity, or vice versa. And this really requires some knowledge of the unit circle. If you think back to your unit circle, cosine is 0 over here and over here. I'm lying. That's when cosine is 1. Cosine is 0 here and here. At pi over 2, 3 pi over 2. So really I want to ask myself, what value of t is going to give me pi over 2? Well, if t is 3, 3 and 6 cancel and I get pi over 2. So t equals 3 is a good choice. That's between 0 and 12. The next time I get one of those two numbers, 3 pi over 2, might be at 9. If I put a 9 in for t, I get 9 over 6, which reduces. And the next time wouldn't be until a number bigger than 12. I believe the next time is like 15. That's too big because we're only looking from 0 to 12. So I've got my critical numbers. I'm going to make a little number line, starting at 0, ending at 12. Unit circle is going to help me out here too. If I choose a number between 0 and 3, that means I'm over here in quadrant 1. Because plugging in 3 for t gives me pi over 2. In quadrant 1, cosine is always positive. Plug in a number between 4 or bigger than 3 up to 9. That means I could choose anything in either one of these two quadrants. No matter what I choose, I'm going to get a negative cosine value. Then I can choose something bigger than 9 up to 12. That's going to finish the circle up for me. Positive cosine values. Really, this is checking your knowledge of the unit circle as much as it's checking calculus. And we're asked for moving to the left, so we have to give the intervals. It's not even asking us for an explanation. We just have to say 3 to 9. You say that, you get your full credit. To get the points, 2 points, you should have said somewhere in here that you got v of t equals 0. So they're going to give me a point for writing that down. They're going to give me a point for the correct interval, which was the 3 to 9. This whole part was worth 2 points. That's Part B is asking us to write, but not evaluate, an integral expression that gives the total distance traveled by the particle from 0 to 6. So hopefully we've got something like a 0 to a 6. Total time traveled means we want total distance. So to get, what do we take the antiderivative to get distance? Velocity. If we stop here though, we're not going to get the point. That right there told us our total displacement. We don't care how far we're displaced. Maybe we went 5 miles down the road, came 5 miles back. Our displacement is 0, but our total distance traveled would be 10 miles. The way we make sure we take care of the total distance is we get rid of the sign in front of velocity. We want to see exactly, we want to consider all of our velocities to be positive, absolute value. That way we can see our total distance traveled. If it asked us for how far we were from the starting point, then we would take away the absolute value symbols. So that was kind of tricky. But that's it for part B. This one was not worth very much. It was worth for only 1 point. On to part C. Part C asks us to find the acceleration of the particle at time t. We should know that acceleration is the derivative of velocity. We were given the velocity equation. We just find the derivative. Derivative of cosine is negative sine. Leave the inside alone. Chain rule says multiply by pi over 6. Good enough. You can put the pi over 6 in front if you want. It doesn't matter. Now it's asking you, is the speed of the particle increasing, decreasing, or neither at time t equals 4? Speeding up and slowing down refers to checking acceleration and velocity. As you should remember, if acceleration and velocity have the same sign, we're speeding up, or you could say speed is increasing. If acceleration and velocity have different signs, you're going to say that the object is slowing down or the speed is decreasing. So let's take a look. Let's find the velocity at 4. We have the equation for velocity up in the given information. 4 pi over 6, which reduces to 2 pi over 3. Once again, the unit circle strikes. If we know our unit circle, we know that that cosine value is less than 0. Specifically, it's negative 1/2. I don't care what it is exactly. All that matters is negative. Now we have to find our acceleration at 4. If we end up getting a positive number, the signs will be different, and we will say slowing down. If we end up getting a negative number, we'll say the signs are the same, speeding up. So let's take a look. Negative sign of 4 pi over 6 times pi over 6. Again, 4 pi over 6 reduces to 2 pi over 3. Thanks to our unit circle, we know that the sign value of 2 pi over 3, which is the y value, is positive. Negative pi over 6 times a positive is a negative. Specifically, sine of 2 pi over 3 is square root of 3 over 2, but I don't care about that. I just care that this whole thing is going to be negative. And my conclusion, since both of the acceleration and velocity were negative, I must be speeding up. So I say speed is increasing. And that's not good enough. It's asking for a reason. You should put that in your sentence. You can say something like, because at t equals 4, acceleration and velocity are the same sign. You can even say they're both negative, but you could just say they're the same sign. What's going to happen to a lot of people, and I'm guessing this is where some points were cost, is people are going to just plug in 4 to acceleration. You're going to say, oh, that was negative, so I'm slowing down. That logic isn't quite right. So let's talk about how that might play out in the points. Part C was worth 3 points. First point came from a correct A of t. Then it says 2 points for conclusion with reason. I don't know if that means they're going to give you a point for saying this with no reason. I'm not sure. But it says 2 points for explanation with reason. So it's always best to have your reason if it asks you for one. I wouldn't be surprised if you lose both points there. Hopefully, you'd get one. I don't know. That's it for part C. Let's take a look at part D. Part D asks us to find the position at time t equals 4. And the part that a lot of people are going to forget is to use this information. At time t equals 0, we're at position -2. So what I'm worried some people might do is just go 0 to 4, antiderivative of v of t dt. That's great, but that tells you how much you changed from 0 to 4. It doesn't take into consideration with where you started. And you need to include that -2 plus. If you forget to do that, you're going to definitely lose some points. Now you have to take that antiderivative. So let's do that as a little side problem. We want to know the antiderivative from 0 to 4 of v of t dt. That looks like a u substitution problem, so we have to say something like u equals pi over 6 t du equals pi over 6 dt. Get rid of that constant. 6 over pi du equals dt. So now we've got this set up a little bit. We can start using it. I can say -2 plus, it's going to hold off on putting numbers up there. dt gets replaced with 6 over pi du. Pi over 6t gets replaced with u. I held off on putting in my limits because they're not 0 and 4 anymore. I have to use my u to figure out new values. Plug 0 into that and I end up with 0. Plug 4 into that, I get 4 pi over 6, or 2 pi over 3. Now I don't have to go back and use the x, or the t at all anymore. I just have to evaluate this and I'll be done. Fortunately, that's not a bad antiderivative. -2 plus 6 over pi sine u evaluated from 0 to 2 pi over 3. Unit circle strikes again. We know what the sine of 2 pi over 3 is, or at least we should. I'm going to say -2 plus, or we could put a 6 over pi on the outside of this whole thing. It's a constant. Plug in 2 pi over 3. Sine of 2 pi over 3 is square root of 3 over 2. You have to just know that. Sine of 0 is 0. This is good enough for a final answer. You could clean it up, but then you're just giving yourself an opportunity to make an arithmetic mistake. So I would say stop there. Once you've got this, you're done. There were no units given, so we can't say feet or whatever. It'd be nice if they gave us units, but it's actually nice that they didn't, because you won't miss points now. The way the points fell out on part D, you got a first point for a correct antiderivative. So we're looking for some substitution, should eventually get down to right here. This is where you get that first point. You get a point for using the initial condition. So if you at least tried, you got yourself a point, even if your antiderivative was wrong. And of course the last point comes from final answer. And that's it for part D, and that's it for AB 2012, question number 6. Have an awesome day.